So we are done discussing balancing redox reaction in acidic solutions. So now we will be discussing balancing redox reactions in basic solutions. So we need to remember that in balancing redox reaction in basic solutions, we are adding water and hydroxide ion. So, in our previous discussion, kapag sinabi nating acidic solution, nag-a-add tayo ng hydrogen ion and water. But right now, we will be adding water and hydroxide ion. So, when we say, we meant to say that kapag nag-add tayo ng water, let's say on the reactant side, mag-add din tayo ng hydroxide ion on the product side. So, we need to remember na hindi pwedeng mag-add tayo ng water and hydroxide ion on both sides. So, dapat magkabilaan. Okay, so let's have some examples. So, write a balanced equation for the reactions between the permanganate ion and hydroxide ion, hydrogen peroxide in basic solution to form manganese dioxide ion. So, ayan. So, step 1, write a skeleton equation for the reaction. So, isulat lang natin ang equation natin. Next thing is to assign oxidation numbers to atoms on both sides of the equation. So, we have discussed already how to determine the oxidation numbers. So, I hope na marunong na kayong lahat because again, you cannot balance redox reactions if you do not know how to determine the oxidation numbers. So, dito muna tayo sa first compound, first ion, okay? So, Mn dito sa reactant side natin, we have MnO4 negative. Okay, so we need to remember, again, di ba guys, we have discussed na kapag polyatomic ion, the sum of the oxidation numbers is equal to the charge of the ion. So in this particular example, ang charge ng ating ion is -1. So, -1 is equal to, we know that the oxidation number of oxygen is always -2. So, this will be 4 times -2 plus the oxidation number of Mn. So, -1 minus -8 will be, -1 minus -8 will be 7. So, the oxidation number of Mn is equal to 7. The oxidation number of Mn is 7. So, doon naman sa product side, dito sa MnO2 natin, for MnO2, again, sabi natin, diba, that the sum of the oxidation numbers of neutral compound is equal to 0. Diba? Kasi neutral compound siya, wala siyang charge. So, the sum of its oxidation numbers, the sum of the oxidation numbers of the elements involved is equal to 0. So, this will be 0 is equal to, so the oxidation number of our oxygen is -2. So, 2 times -2 is equal to -4. So, plus Mn. So, the oxidation number of our Mn would be will be 4. So, Mn will be 4. Kasi, diba, -4 plus 4 is equal to 0. So, on the reactant side, we have Mn equals +7, and on the product, Mn is equal to 4. So, let's have the hydrogen peroxide naman. For the H2, H2O2, for H2O2, since this is a neutral compound, the sum of the oxidation number is equal to 0. So 0 is equal to, for hydrogen peroxide, ang sabi is, let's go back. Saan na yun? Ayan, for hydrogen peroxide, the oxidation number of oxygen is negative 1. Negative 1 for our hydrogen peroxide. So, this will be 2 oxygen atoms times negative 1, since this is hydrogen peroxide, plus 2 times 1. So, for our hydrogen, for our oxygen, negative 2, the oxidation number of our oxygen is negative 2, okay, for our oxygen. The oxidation number is 2 times negative 1. Ayan, oxidation number ng ating oxygen, 2 times negative 1. So, negative 2 on the reactant. For the product side, our oxygen here, the oxidation number of oxygen, since this is element by itself, the oxidation number of our O will be 0. So, O is equal to 0. Okay, so after determining the oxidation numbers, we will determine which atom are oxidized and which are reduced. So, we will determine which is reduction and which is what do you call this, oxidation. Okay, so let's see for our MnO4, Mn and MnO2. So ang ating oxidation number is from 7 to 4. So this is reduction since bumaba ang oxidation state niya from 7, ayan, from 7 naging 4. So our MnO4 is the reduction. For our hydrogen peroxide naman and oxygen, so from negative 2 naging 0 siya, so nag-increase ang oxidation number niya, so this is oxidation. After determining which is the reduction and which is the oxidation, we will divide the reaction into oxidation and reduction half reactions and balance this half reaction. So we will proceed the same principles with the balancing acidic solutions. Again, the same principles lang ang fina-follow ng balancing basic solutions with acidic solutions. Ang pinagkaiba lang again is that kapag sa basic solution, nagdadagdag tayo ng hydroxide ion and water, while in acidic solution, nagdadagdag tayo ng hydrogen ion and water. Okay, so na-determine na natin kung saan dito ang reduction. So, for our reduction, nag-decrease ang oxidation state from 7 to 4. Okay, so unahin natin i-balance ang ating oxidation. For our oxidation, we have, for our oxidation, ano na yung oxidation natin, balikan natin yung oxidation natin from 0 to negative 2. For our oxidation, our oxygen, ang ating oxidation number is from negative 2, negative 2 to 0. So, the first thing that we will do is to balance the oxidation number. So, step 1 natin, step 1 is to balance the oxidation number. Balance the oxidation number. So, in this half reaction, di ba, 0 to negative 2 yung oxygen natin. So, for us to balance this, for us to balance the oxidation number, mag-add tayo dito ng plus negative 2. Plus negative 2. Plus negative 2, since, di ba, negative 2, dapat equal siya. Etong oxidation number ng reactant side natin must be equal to the oxidation number of our product side. So, dito, negative 2 yung oxidation number ng ating reactant side. So, let us balance the oxidation number. So, from negative 2, naging 0. To make it negative 2, then dito sa product side natin, we will add negative 2. Kasi kung dito tayo mag-add ng negative 2, hindi pwede. Kasi negative 2 plus negative 2 is equal to negative 4. It's not equal to 0. So, para mabalance na lang sila, mag-add tayo dito ng negative 2. So, ang mangyayari, magiging H2O2 will yield O2 plus, nag-add tayo ng negative 2, so 2E negative, ayan, 2 electron, nag-add tayo ng electron ng negative 2, kasi 2 times negative, diba, negative 2. So, the next thing that we will do, since nag-add tayo dito ng negative 2, the second step, so step 2 is to balance the charge. Remember that charge is different sa oxidation number. Sa charge natin dito, our charge, may nakikita ba tayong charge dito sa reactant side? Wala. So, from 0, the charge is from 0, kasi wala naman tayong charge dito sa reactant side natin. So, from 0 to, ang charge ng product side natin is 2 times negative. So, this is negative 2. Meron tayong 2 electron dito. Since, di ba, ang charge ng electron is negative, so we have negative 2. So, for us to balance this negative 2, anong idadagdag natin? Diba? Sabi natin in balancing basic solution, we will add hydroxide ion and we will add hydroxide ion and water. So, dito, to balance this negative 2 here, diba? Mag-add tayo dito ng hydroxide ion. Remember that the charge of hydroxide ion is negative. So, ang mangyayari ay mag-add tayo dito ng plus, since we have negative 2 here, dapat meron din tayong negative 2 na charge dito sa kabila. So, this will be 2 OH negative. Yan. So, pareho na, balance na yung charge natin. So, from negative 2 is equal na sila sa negative 2. So, this will become 0. Oops. So, from dito, meron tayong 2 times negative is negative 2 is equal to din. So, equal na yung charge nila. So, step 3. So, the step 3 is to balance na natin yung atoms na involved dito. So, step 3, since we added hydroxide ion on the reactant side, we will add water on the product side. Diba? Sabi natin, if we add hydroxide ion sa kabilang side, mag-add tayo ng water sa kabilang side. So, in this particular example, we added hydroxide ion here. So, mag-add din tayo dito ng water. So, for our step 3, addition of water. So this will become okay. So, mag-add tayo dito ng water. Plus H2 plus H2O. But, we need to take note, guys, na this is balancing, di ba? Balancing. So, the atoms of each element must be equal. Must be balanced, di ba? Kung ilan yung atoms dito sa reactant side natin, the same din dapat yung atoms ng element dito sa product side natin. So, in this example, dito sa kabila, meron tayong dito sa reactant side, we have on the reactant side, we have H is meron tayong 2, 4. So, ang H natin is equal to 4. Dun sa oxygen, ang H natin is equal to 4. For oxygen, we have 4 din. And on the reactant, on the product side, ang H natin is 2. Ang H natin is 2 and our oxygen is 2, 3. Our oxygen is 3. And our oxygen is 3. So, hindi sila balance. So, i-balance muna natin yung hydrogen. So, we have 4 here, we have 2 sa product. So, for it to become balanced, mag-multiply tayo dito ng 2. Para maging 2 times 2 is 4. So, balance na sila. So, let's check. Here in the reactant side, meron tayong 2 plus 2 hydrogen. So, we have 4 hydrogen. Dun sa oxygen naman natin, we have 2 here. So, 4. Okay na. Dito naman sa product side natin, we have 2 atoms of oxygen plus 1 times 2 is 2. So, meron na tayong 4 oxygen. And for our H, we have 2 times 2 is 4. So, balance na. Okay, for our next na half reaction, sa reduction half reaction, the same thing. The same thing ang gagawin natin. So, ang oxidation number kanina ng MnO4 natin and MnO2 natin is 7 to 4. So, this is from positive 7 to positive 4. So, again, hindi pareho yung oxidation number ng both side. So, mag-a-add tayo ng electron to balance the oxidation number. So, ang first step natin is to balance the oxidation number. So, mag-a-add tayo on the reactant side ng plus negative 3. Kaya, meron tayo ditong plus 3e negative. Next step is to balance the charge. So, for the charge, ang charge natin is, okay, ang charge natin ay, okay, for the reactant side, tingnan natin dito, negative 1. Ang charge ng polyatomic natin is negative 1. So, negative 1 plus 3 times 3 electron. Okay, plus 3 electron plus negative 3. It's negative 4. So, this is negative 4. While on the product side, makikita natin dito na wala siyang charge. So, the charge is 0. Okay, so from -4 to 0, so we need to balance the charge. So in balancing the charge, this is a basic solution. Ang idadagdag natin is, ginawa natin kanina, OH. So this will become MnO4 negative plus 3E negative will produce MnO2. So, from -4 to 0, mag-a-add tayo dito sa kabila ng, to make it -4 din on the product side, mag-a-add tayo dito ng 4OH negative. 4OH negative. Para maging, para ang charge ay maging -4 sa product side, we have -4, and on the reactant side, we have 4 times negative is equal to -4. So, equal na yung charge nila. So, since equal na yung charge nila, we will add water. Since this is basic solution, again, mag-add tayo ng water on the product side, on the reactant side, since nag-add tayo ng hydroxide ion on the product side. So, let's copy this one. So, MnO4 plus 3E negative. So, dito meron tayong, okay, let's balance the atom. Let's add water muna dito sa kabila. Plus H2O. And then after adding H2O, after adding water, we will balance the atom na. So, on the reactant, for oxygen, we have 5. We have 5 oxygen atom, and for our hydrogen, we have 2. For the hydrogen, we have 2. On the product side, for oxygen, we have 2 plus 4 is 6. For oxygen, we have 6. And for hydrogen, we have 4. Okay, so first let's balance the hydrogen. So, dun sa reactant side, we have 2 hydrogen atom, and on the product side, we have 4 hydrogen atom. So, we need to multiply 2 dun sa reactant side natin to balance the hydrogen. So, kapag nag-add na tayo ng 2 dito sa products as a reactant side natin, let's check kung balance na. So, we have 4 oxygen atoms plus 2, so we have 6. For our hydrogen naman, we have 2 times 2, we have 4. And on the product side, we have our oxygen is 2 plus 4 is 6. For our hydrogen, we have 1 times 4 is 4. So, balance na. So, kapag balance na yung mga half reactions natin, we will recombine it. We will recombine the half reactions. So, i-copy muna natin tong balance na oxidation reaction natin. And our balance reduction reaction. Okay, so just equalize the um, the electron transfer, di ba? For the balancing acidic solution, inequalize natin yung electron transfer. Na inequalize, ibig sabihin, the number of electrons on the oxidation reaction must be equal to the number of electrons on the reduction reaction. So, dito we have 2 electrons, dito we have 3 electrons. So, magmumultiply tayo ng 6 dito sa una, we will multiply 3. Dito naman sa reduction natin, we will multiply 2. To make it okay, to make it 3 times H2O2 is 3H2O2. 3 times 2OH is 6OH. 3 times 1 is 3O2. 3 times 2 electron is 6 electrons. And 3 times 2H2O is 6H2O. Dito naman, 2 times MnO4 is 2MnO4 plus 2 times 3 electrons is 6 electrons, and 2 times 2 water is 4 water. 2 times MnO2 is 2MnO2, and lastly 2 times 4 hydroxide ion is 8 hydroxide ion. So, after nating ma-balance yung electron transfer, we will recombine our half reactions. So, i-recombine lang natin yung nasa reactant and nasa product side. So, this will be plus our reduction plus and this one plus our reduction. Ayan. So, just simply recombine it, guys. 3H2O2 plus 6OH plus 2MnO4 negative plus 6E negative plus 4H2O, ayan, is equal to 3O2 plus 6 electron plus 6 water plus 2MnO2 plus 8OH. And then, simplify. Okay, let's simplify. So, dito sa reactant side natin, 3H2O2 plus dun sa kabila, meron tayong 8OH. So, 8OH minus 6OH. Kapag, okay, ganito na lang. I-simplify na lang muna natin para hindi kayo malito. H2O2 plus 2MnO4 negative. And itong 6E negative natin dito, ilipat natin sa kabila, minus 6E negative. Kasi nilipat natin sa kabila, kaya naging minus. Minus 6E negative. This will produce 3O2 plus 6H2O minus, sa kabila magiging minus 4H2O plus 2MnO2 plus 8OH negative, 8 hydroxide ion. And meron din tayong hydroxide sa kabila kanina na 6. So, ililipat lang natin sa kabila, kaya magma-minus tayo. Minus 6OH negative. Simplifying, magiging 3H2O2 plus 2MnO4. 6 minus 6 is 0. This will yield 3O2. 6H2O minus 4H2O is 2H2O. 3O2 plus 6H2O minus 4H2O is 2H2O plus 2MnO4 plus 2MnO4 MnO2 and lastly 8 hydroxide ion minus 6 hydroxide ion is 2 hydroxide ion plus 2 OH negative. So that's it. That's our final answer. So ganun lang ang mag-balance ng basic solution. That's our final answer.